In this podcast, I am going to answer question 1. Question 1 wants us to find these two ratios here, given that the parallelogram above and that P is the midpoint of A and B and Q is the midpoint of B and C. In order to find these ratios, first we must define these two lines. Now, the general form of a line or a point specifically on that line would look something like this. R, the point, is the vector at the start or a point at the beginning of the segment of the line we're considering. We might call this alpha times some lambda that's constant, plus 1 minus that same lambda times the point at the end. We might call it beta. Okay? The point we will choose to fix is this point of intersection, because that is common to both lines, and will allow us to simplify later on in the process. We will define the two lines at that point as follows. AQ is R, which is what we're going to call this point A, lambda 1 plus 1 minus lambda 1 Q, where Q is the vector to the point capital Q, A is the vector point capital A, and equally we could do the same for the line PD, with of course the same point R, P lambda 2, note the different lambda, 1 minus lambda 2, little d. Now we've done this, we can already state equations for the ratios, which is that the ratio ARRQ is equal to 1 minus lambda 1 over lambda 1, and the ratio PRRD is equal to 1 minus lambda 2 over lambda 2. So therefore, our problem amounts to finding the lambdas. This is where the affine transform about the lines that we've stated here, about the general point, the point R. In order to fill in all this information, specifically these 4 vectors, information comes in. T. By theorem 4.1, ratios of lengths are preserved. So in order for us to fill in all this information that we don't need, we can use the affine transformation to simplify the problem. And because it's an affine transformation, the ratios of the lengths will be preserved. Which means that we can be safe in the knowledge that the ratios we calculate, the lambdas and then the ratios that we get from them, will be accurate, will be the right ratios. We'll use this to simplify our workings, our calculations effectively. And we are given in the question that this affine transformation maps A to 1, 0. We are to determine what B is, C to 1, 0, and D to 0, 0 to the origin. Now we ask ourselves what would be simple. And we conclude that what is similar, not as in similar shapes, but what is sort of like a parallelogram, but is easier, and we think, well, what about square? And this makes sense by the 3 points we are given as well. If we call this D here, that's the origin. And then we know we're given a 1, 0, our C. That would be our B, if we're following the pattern in the parallelogram. Yes, and so it is clear from this that the square makes sense, and that B is the point 1, 1. 1, 1. We can also, to this square, add RP and RQ, which are still the midpoints because the ratios of the lengths are preserved. It is clear that P is the point 1/2 and 1, and Q is the point 1/2. And so now we can fill in the information on the lines, on the equations. So equation 1 can now be written as 0, 1, lambda 1, plus 1 minus lambda 1, 1/2. And equation 2 can be written as 1/2 1 lambda 2 plus 1 minus lambda 2, 0, 0. What's quite nice about the 2 then is that cancels. The equation 2 is that cancels. And so, we now have more information. In fact, our only unknowns now are the lambdas, which is the position we wanted ourselves to be in. And we also note that we can make these two things equal, because they're both equal to the same point. And so we can further write that 1 minus lambda 1, 1/2 1 plus lambda 1 is equal to 1/2 lambda 2 lambda 2. This gives us a system of simultaneous equations that we can solve by substitution. Two minus 2 lambda 1 is lambda 2, and 1 plus lambda 1 is 2 lambda 2. By substitution, we get 1 plus lambda 1 is 4 minus 4 lambda 1, which gives us lambda 1 is 3/5. And then by substituting this into equation B, we get lambda 2 is 4/5. We can then use this to calculate our ratios. ARAQ therefore is 1 minus 3/5 over 3/5, which is 2/3. And PR over RD is 1 minus 4/5 over 4/5, which is 1/4. And hence, we have calculated the two ratios, and we have stated the identity of point B under the affine transformation.